Part 2 of 5.9 is going to talk about multiplying and dividing complex numbers. We're still going to use our idea about variables. If I can do it with a variable, if the rule applies for a variable, the rule probably applies for I. So when I see this problem right here, this is my classic FOIL problem. So I'm going to take my first two terms times each other, my outside terms times each other, my inside terms times each other, and my last terms times each other. Now 3i times minus 5i, remember, is minus 15i squared. Now a couple of things happen. Your outside and your inside are still going to combine, but I have some simplifying to do right there. So I have 7 plus 16i minus 15 times minus 1, because I squared is minus 1. Well, minus 15 times minus 1 becomes a positive, so I have 7 plus 16i plus 15. Now I have two real components that need to be combined, and so I really have 22 plus 16i. Usually, when you FOIL with imaginary numbers, everything will boil down to a complex number. So if you end up with a trinomial or you end up with 4 terms and nothing is combining, you probably want to go back and take a look, because usually they will boil down to a complex number. Now, dividing by complex numbers really falls under our radical rule of needing to use the conjugate or some sort of rationalizing the denominator. And I'm going to put it in quotes because it's not exactly, but it has that same feel. You need to get that I out of the denominator. So if you have a complex number, remember we're going to treat it by the single number, and we're going to multiply by the conjugate. And remember that is the opposite sign of the same numbers. So the bottom, when we do that conjugate, remember that's always going to become a squared minus b squared. This numerator happens to be a distributive property. So I have 15i minus 10i squared all over 3 squared minus 2i, the quantity squared. So I have a lot of cleaning up to do. So I have 15i. This minus I squared here becomes minus 1. And so minus 1 times 10 becomes plus 10, all over 9 minus 2 squared is 4. I squared is minus 1. And so I have 15i plus 10 in my numerator, all over 9 minus 4 times negative 1 is a plus, all over 13. That's in simplest form, and I no longer have an I in the denominator. Now this case over here, I don't have to do a fancy conjugation because I don't have that sum or difference. I just need to get rid of this singular I. Easiest way to do that is to multiply top and bottom by I. So my denominator becomes 5i squared. My numerator, I have a distributive property, so I have 4i minus I squared. Do some cleanup. 4i minus 1 all over 5 times minus 1. And so I have 4i plus 1 all over 5. And that's the simplified form. So that ends all of the material in 5.9. Just keep in mind that I is an operation. I squared equals negative 1. The square root of negative 1 equals I. And that when it comes to operations, they behave just like variables.